Did you learn about slope last lesson? Here's the ground. And this is on a map. And I'm going to draw a hill. So here's one hill. Right? Then there's another hill. And then there's a mountain. And then there's another small hill like this. Which one do you think is going to be harder for you to climb?
Mountain.
The M, right?
Yeah.
Why is that?
Because it's a lot more steeper.
Thank you. Steep. I just heard one word. It's steeper. What is steeper? This one would be steep, and this would be less steep, isn't it? What are you referring to when you talk about steep? You're referring to this kind of line idea, isn't that right? I could actually give you another picture to think about. So imagine here's the ground, here's a brick wall. Now I'll put a ladder. One ladder's like this, one ladder's like that, one ladder's like this. Which ladder would require more energy to climb?
Ladder A.
Ladder A.
Why?
It's higher.
Yeah, high is not wrong, but I think the main difficulty is the steep. It is the steepest, isn't that right? This C would be the easiest because it's the one is less steep than everyone else. Okay, so the slope, or another word for slope is actually the word gradient, is actually equal to a measure of steepness. So the symbol the mathematician used for gradient, anybody know?
Isn't it a big M, sir?
Yeah, a little m, that's right. So if I draw three lines again, like this, line 1, line 2, line 3. Line 1, I can let m1 equal the slope of line 1. M2 equals slope of line 2. M3 equals slope of line 3. Which has the greater value, M1, M2, or M3? Value as in a number, if you can measure it in terms of number. Look at the three lines, line 1, line 2, line 3, right?
Yes. The greatest value?
This is the ground here.
Yes.
And the slope of each one, of line 1 is M1, the slope of line 2 is M2. Have you learned about subscript? I'm sure you have, because X1, Y1, Y2, and all that, right? Which value, if you were to be able to measure it as a value, which slope is the greatest?
I don't get what you mean by
Okay. Slope is gradient, right?
yeah.
Which we say is the measure of a steepness, isn't that right?
Yes.
Measure of steepness. All this here is all qualitative, which means we're using quality to describe slope. Yeah. Imagine if I can describe it in terms of a number or a quantity. Which of the lines here, line 1, line 2, line 3, would have the greatest slope if you can measure it as a number?
1.
Why is that?
It's the steepest.
That's it. Thank you.
I'm
That's
guessing
correct. Well done. Easy. So my question is, if slope can be quantified, which line has the greatest M? And Kento's answer is
1.
since it is the steepest.
Yes.
Yeah, that's it. That's qualitative aspect at this point. Are you clear? Now, let's go and look at the quantitative point of view. What am I studying here? What am I going to look into just by looking at the title? What do I mean now by quantitative view of gradient or slope? Because gradient is slope, same word. Not same words. Different word, same meaning.
Is it like how to find like the slope over the line?
Close, just add how do you find a value? We want to put a value to it. That's what quantitative mean. Are you clear, guys? So if you look up here, this is all qualitative. Are you clear? So I should give you a title here, up here. A qualitative view of a nail would be like, okay, he's got black hair. He's a male. He tends to like dark clothing, and he plays the guitar. Okay? If I was to describe him quantitatively, which means more numerical value. So I'll say, okay, Nell is 15 years old. He's, I don't know, 13, 14. He's 170 centimeters tall. His weight is 110 kilogram. That's a quantitative view of a nail. So earlier we look at a qualitative view of slope. Now we want to look at number crunching point of view of slope. So here's a question for you. I have a brick wall like this. I have a ladder, one fixed ladder only. That ladder is AB. I could move that ladder to a new position. So that ladder can come like this. This would be A dash, B dash. So when I move the ladder to closer to the wall, the foot of the ladder, the foot A is moving closer towards the brick wall, isn't that right? Now, which position shows the steepest position of the ladder? Come on, people.
A red.
Don't say A red, it's A dash. A dash, B dash. Is that clear?
Okay.
So A dash, B dash is steeper than AB. Now, note, length AB is equal to length of A dash, B dash. Oh, Ariel?
Because the ladder was moved forward.
Yeah, what you're trying to say is the same ladder. Now, we are aiming to try and find a way in which we measure the gradient for the two different positions of the ladder. Now, notice something here. There's two things we should notice. One, can you see that at position A and B, the green one, there is this horizontal, this is called the run distance. And here's the rise distance. When you move A to A dash, what happened to the run distance?
Decreases.
Good. The run distance becomes smaller. What happened to the rise distance?
It increases.
So the rise increases and the run decreases. Let's define. You know what define means? We make something happen, right? The slope of a line will be the rise distance divided by the run distance. I'm going to define that. Why do you think I defined that? So let's look at the slope of, so I'm going to use that now. The slope of AB would equal to, let me call this point here C. It will be what? What is the rise distance for AB? I'll start off. Would you agree it's equal to BC? This. It's the length of BC. Divided by, what is its run distance, Ariel?
AC.
AC, good. Also, what's the slope of A dash, B dash? It's the length of
B dash C over length of A dash C, yeah.
Good, excellent. Can you see that there are two fractions here? The question is, which fraction is the bigger one?
I know which one's bigger. I just need to find a way to explain it. So
Okay. How long do you need? 2 years?
give me 30 seconds, sir.
Okay, that's very optimistic. I like that though.
So the slope of A dash B dash, that fraction is bigger because the rise is bigger than the run, so that means it's more than a whole.
Anybody want to dissect up a nail, like debate with him? How do you know that for the slope of AB, that the rise BC is not bigger than the length of the run AC? Because if the rise of BC is bigger than run AC, it's still be greater than 1.
You can't really tell, but you can tell that
If you can't tell,
different-
then I win, right?
not necessarily, sir.
Go ahead.
It's
Make me lose.
it's very obvious that B-C is more than twice as big than A-C, whereas BC is, if it's bigger, it's only marginally bigger. So
Well, it's still
it
greater
was-
than 1. I'm
Sorry,
using your
sir?
reasoning. You said it's greater than 1.
Okay, then I have to fix my reasoning, sir.
That means I checkmated.
Okay. Good game, sir.
It wasn't a game to me at all. It was like brain dead to me. So what Anel did is fantastic. He proposed something, and that's good. Our aim is to, as his good friends, is to try and counterproof him. To answer this question, you just have to. You've been asked to compare two fractions here. BC on AC, comparing that to B-C to A-C. Which is greater length, BC or A-C? Can you see that B-C is clearly greater than BC? So far, I just proved to you that the numerator of the second fraction is bigger than the numerator of the first fraction. Now I'm going to look at the AC and B and A-C, which is greater?
AC.
Okay, I just take a nailed answer. AC is greater, right? So now come back. You got BC. This one is larger, and this one is larger on top. Which fraction is bigger? When I say larger, I'm talking about AC here, B-C. One fraction has a larger denominator, but a smaller numerator, and this is smaller. 10 is smaller than 9, say.
Wouldn't it be the second fraction, because if the smaller fraction is on the bottom and the larger fraction is on the top, then it'll be more holes?
Yes, that's right. Excellent. The second fraction here is the larger fraction, because the smaller the denominator, there'll be more holes. Excellent reasoning. I can say that which fraction is bigger? It'll be this one. So which slope is greater slope then?
This the second slope.
Yep, and that's how we described slope before. Okay, so therefore the slope of A dash B dash is greater than slope of AB, because it has a larger ratio of rise to run, or larger fraction, instead of saying ratio. I am now going down to create a formula to calculate this. Now we're looking at the gradient formula. You're given any 2 points on a line. You can calculate the slope of the line by using this formula. So the slope, and this is the definition as we said before. So now I'm going to give you these 2 points on a Cartesian plane like this. Here's A, x1, y1, B, x2, y2. I want you to measure or calculate the value of the slope of AB. What we're going to do is we're going to draw again a horizontal line like this and a vertical line at B, and that distance from here to here would be the run, and that distance from here to here would be the rise. So can you see that the rise is nothing more than y2 minus y1, and the run is nothing more than x2 minus x1, because that's x2 here and that's x1 here, and this rise here, that's y2, and this is y1 right here. Now can you see from A all the way to that point. Let me give that point this intersection point here, let me call that C again.
Mm-hmm.
Can you see that AC is the horizontal run distance from A to until you get to the point right directly underneath B?
Yes, I do.
Do you understand that that distance can be taken, can be measured by taking x2, which is this x value here, see it underneath C? The x value is the x value B, which is the same as x value C, isn't it right?
Yeah.
You take that value and you minus the x value here, which is right underneath A. You see A here? X1 is there. X2 is there. So the run distance is the blue distance minus the yellow distance. Do you understand that?
Yes.
And that's how we got this run distance here. Now try to follow the rise distance. The rise distance is, if I run from A to C, I'm now directly underneath B, isn't that right? Now I have to go up all the way up to B. That will be the rise distance, isn't that right? How much I have to rise to go to B.
Yes.
And can you see that at A, I'm actually y1 high at A, if we treat the x-axis as the ground. And now if I'm at C, how high am I?
Y1.
That's it. Thank you. Y1. C is still Y1 because C is on a horizontal line that runs from A, isn't that right? Okay, at B, how high are you from the ground?
Y2.
Excellent. Now what we're looking for is this rise. The rise distance is actually the green value here. Isn't that Y2 minus Y1?
Yes.
So that rise there is that. Are you clear now?
Yes, sir.
Yes, sir.
So, do you now understand this is the quantitative measure of slope? Yeah, or gradient. Same meaning, different words. All right then, students. Have a good night. Yeah?
Afternoon, evening, sir.
Yeah, enjoy your dinner.
Thank you, sir.
Good night.
Thank you, sir.
Good evening.